Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we are going to solve a problem on falling sphere resistance method. So this method actually used to identify the coefficient of viscosity. And in the last lecture, in the last video, we have already discussed the theory of part of this, and also we have derived the equation of viscosity by this method. So based on the concept, we are going to solve a problem in this. So here I have taken a question. A sphere of diameter 2 meter falls 150 millimeter in 20 seconds in a viscous liquid. The density of the sphere is 7500 kg per meter cube, and of the liquid is 900 kg per meter cube. Find the coefficient of viscosity of the liquid. So this is very simple questions, and this kind of questions may be asked in your semester exam as well as in the competitive exam also. So first let's see what are the data are given in this question. So it's very simple to identify the data given. The sphere of a diameter 2 meter falls. Okay, so that means diameter of the sphere equal to you can write 2 millimeter, and which also you can write 0.002 meter, and this is diameter of the sphere. Falls 150 mm in 20 seconds. So that means it is falling 150 millimeter. So that means the length of the sphere, and how much, from which point to which point we are considering that distance. So that is L, we can say this is 150 millimeter. See this, it falls 150 millimeter in 20 seconds in a viscous fluid. You can able to understand when you have seen the previous video, and when you understand the concept of this. Okay, so this one we can write 0.15 meter, and in 20 seconds. So the time taken for this is 20 seconds. This also you can write. The density of the sphere is, density of the sphere equal to 7500 kg per meter cube. Similarly, the liquid which is present, whose viscosity need to be identified, that density also given 900. So density of the fluid which is present, so that is 900 kg per meter cube. Find the coefficient of viscosity of the liquid. So as per this concept, the viscosity we have derived in the last class, the formula is there. So see, the falling sphere resistance method, this is the method I have indicated here. But from this question, how you can identify? Now see, a sphere is there, a sphere of a diameter is there. So sphere concept is there, and is false. This is, so sphere and fall, that means a sphere is falling. Okay, so and remaining things, resistance method means that means we need to calculate the viscosity of the fluid. So from there you can identify this concept belongs to this falling sphere resistance method. So this falling sphere resistance method already we have discussed in the last lecture. So this kind of diagram we have considered, and this is the liquid which is present here, and this container is supposed to be insulated, and or you can say it is a constant temperature bath, so that there is no temperature supposed to be transferred to the system, and the liquid which is present should be at a constant temperature, so that there should not be any effect on the viscosity, because we know that viscosity is directly proportional to the temperature. If temperature changes, the viscosity is also changed. Now here one sphere is there. Let's take a sphere, and this sphere is moving with a velocity, and let's take another one position, and where this sphere is moving with a constant velocity, this one. So this is the movement is there. Okay, and this velocity is suppose u. This is the position of 2. So this length, actually this is the distance traveled. It's talking, it's 2 millimeter falls 150 millimeter. So this is the distance actually, and in 20 seconds. So this much distance traveled in 20 seconds. Okay, so this mu equal to, in our last lecture already we have derived this equation. We got this formula, gd square. I think the bracket will be started here, and this is rho s minus rho F bracket close divided by 18 U. Okay, so this is the formula is for this. Now here G value we know, D is already given, rho is given, rho S is given, rho F also given, 18 into U. So the thing is only you need to calculate the value of velocity U. So U equal to the distance by time. So the distance which is covered, how much distance is covered? 0.15 meter. So 0.15 meter is covered within 20 seconds. So if you solve this, like if you just calculate this, you'll get the value of 0.0075 meter per second. So this is the velocity, which is distance by time we can calculate, and remaining terms are is given here. So now we'll just put the value of all these things, 9.81, and this is d square, that means 0.002 square bracket start 7500 minus this is 900 bracket close and divided by 18 into 0.0075. So with the help of calculator you can easily do it. So let's see, 9.81 into 0.002 to the power 2 and multiply 7500 minus 900. So this will be 6600 25.89 divided by, bracket will start 18 into 0.0075 bracket close 191.84. Yeah, this is 191.84 what we got, and so this is the value of viscosity. I hope this answer is correct. Yeah, so you can write 191.84, or else we can do one thing, we just can, yeah, once more we can try the value what we have taken, 9.81 into 0.002 into this is square is given, yeah, into 0.002 into 7500 minus 900, which is 6600, yeah, 0.258984, yeah, and divided by the same value I think we got in the last time, divided by, we can do bracket start 18 into 0.0075 bracket close. Okay, no, last time I think we got then 25 point something we got, because now this time you see, last time we got 191 and this time we are getting 1.9184. Anyway, so maybe I think this is correct because we have done one by one properly. So 1.9184 Newton second per meter square. So this is the viscosity value, or if you want to convert it into poise also, you can just write it, just multiply in that 10, and we can write this is 19.18 poise. This is the value of viscosity. So I hope you understand how to solve this problem. If this kind of questions are given, and it's very easy to identify, only you need to remember this formula. If you don't know the formula, how to remember, then we need to go for the concept of this. That means how to derive these equations. So this equation derivation are also easy, but that also need to be remembered. And remaining things are as simple as that. So I hope you understand. If you are having any doubt in this, you can give a comment on the comment box. Thank you all.